Hello, learners. Welcome to the MOOC course on Digital Humanities Theory and Practice. So, I welcome you all. In our previous session, we covered advanced research strategies for searching the open web. Now, today, we move on into a closely related but distinct area: academic databases and repository. Over the course of this lecture, you will learn the difference between indexing and full text databases, get familiar with the major citation databases and Google Scholar, understand how open access repository work, and see how all of this connects directly to digital humanities research. In the last session, we focused on advanced search strategies for the open web, building precise queries with Boolean logic and search operators. Today, we are moving into a related but distinct skill: knowing how to navigate the world of academic databases and repository specifically. This matters because the open web and the world of scholarly publishing are organized in a very different ways, with different access rules, different search logic, and different kinds of overlap between services. By the end of this lecture, you should be able to tell the difference between a database that gives you citation information and one that gives you the full text. Knowing which major databases to turn to for different kinds of academic material. Understand how open access repositories are changing scholarly publishing, and set up alerts so that the new research finds you rather the other way around. We will close by connecting all this directly to the kind of a work you will be doing in digital humanities researches. So these are okay, which we already discussed. So this is the roadmap that we have in our lecture overview. Introduction to the academic databases and repositories. Academic articles are peer-reviewed and edited, distinguish them from most freely available web content. So let's start by thinking about what actually makes an academic article different from an ordinary web page. The keyword is peer review. Before an article appears in a respected journal, it has typically been read and assessed by other experts in the field, and an editor has overseen that process. This doesn't make academic article infallible. Plenty of flawed work gets published, but it does mean a layer of quality control exists that most online content simply doesn't have. I want you to think of an academic journal as an ongoing conversation between scholars across time. When you read an article reference list, you are not looking at you are not looking at a formality. You are looking at the map the author has drawn for you, right? And pointing towards the work they consider the most important in their field. Use that map. Now, the internet has made academic article far more accessible, but understanding how these material are organized remain essential. All right. So, repositories are organized collection that store the research outputs, sometimes openly, sometimes restricted to subscriber. And lastly, not the least, a single article can be listed in over 20 different databases, the result of competing the commercial agreement between journals, publishers, and the database computers. Now, here is something that surprises you or surprises a lot of students. A single article isn't just a single or a single article isn't just sitting in one place online. Because of the tangled communication relationship between publisher, journal, or the databases companies, the very same article might be indexed in a 20 or more different databases, each with slightly different coverage, different access rules, and different search toolkits or tool. Now, this is exactly why understanding how this ecosystem work in a skill itself, and it's the skill that we are building today. Now, indexing or abstracting the databases versus full text databases. So, in indexing, what happens here is it provides citation details, which is author, title, year. Author chosen keywords are not short abstract but not the full article text. Whereas your full text databases will provide you the complete article but are also limited to output of a single publisher or a small group of publishers. Then, these originated decades before the internet as the first attempt to make the article information searchable. Whereas your full text databases are of two types overlap but don't replace each other. Using both is recommended. Lastly, we have in indexing and abstracting databases, because since they don't depend on the full text access, they are more comprehensive than the full text itself, or full text services. Whereas your full text databases open URL links and now bridge the two, letting users move from a citation record directly to the full text via their institution's subscription. So, this distinction is the single most important thing to understand before you touch any academic database. So, let's slow down here and again go back to the current or the present slide and look at that slide. Thinking of an indexing and abstract database like a library old card catalog, it tells you an article exists and who wrote it, when, and gives you a short summary also. But it doesn't hand you the actual pages. These services existed long before the internet, because long before the internet, because publishers were happy to have their articles detailed listed everywhere. It was essentially free advertisement for them. Then full text databases are different. They give you the entire article, but because publisher makes more money selling a text, a full text database is usually tied to one publisher or a small cluster of publishers. This is why you will often find an article citation listed in 15 or different indexing databases, but the actual full sitting is just one or two full text services. So this is why you will often find the article citation listed in 50 different indexing databases, but the actual full text is sitting in just one or two full text services. A common mistake student makes is assuming one database will do everything. It won't. You need both type and increasingly open URL links, such as open URL links are stitching the two together. So when you find a citation in an indexing database, a link can take you to a certain to a straight a link can take you to a straight to the full text if your institution subscribe to it. If you click one of these links and it leads nowhere, that usually just means your library doesn't have access to the practical journal, not the system is broken. Major indexing abstracting databases, like we have OCLC article first, we have ICICI Web of Science, Scopus, Periodical Index Online, and Academic Search Premier, which is also known as IBESCO, and CSA Illumina. I'm not asking you to memorize every name on this slide as if it's a vocabulary list, right? What I want you to take away is a sense of what each database is good for, so that when you are stuck, you know them where to turn, right? So if you need to know whether a nearby library physically holds a journal, OCLC article first has a feature for exactly that. If you're working on something with the real historical depth centuries and old material, the periodical index online is built for that in a way that most modern databases aren't. ISI Web of Science and Scopus are the two heavyweight citation databases, and we are going to spend the next slide specifically on how they work actually. Because tracing the citation is one of the most important, powerful research techniques you will learn in this lecture. For now, just notice that even within the academic databases, there is a real specialization. Some are built for breadth, some are for the historical depth, some are for citation tracking, and knowing which one to reach is half the battle won. Now, both track who cites whom, allowing research to trace the development of the academic researches or debate over the period of time. Now, this one is the most genuinely useful techniques in the entire lecture. So, pay close attention. A citation search flips the normal direction of research. Instead of starting with a keyword and helping to move relevant article, you start with one article or a book or you already knowing it is important. And you ask yourself, who has cited this since this was published? The list of citing work would surface because single one of those authors has already decided for your sources matters enough to engage with. Now, a feature I want you to remember specifically is find related records. This doesn't show to who cited your source. It shows you the other articles and the shared references with it, right? Even if they never cite in each paper specifically or directly, but still that's a great help. Now think about what matters. It can surface a cluster of scholarship working today related questions because they don't have even use and the same vocabulary. Now, in order to moving further, be aware of the limitations of this. Is though if you're searching an ISI Web of Science for an author with a common surname, you might get a flood of irrelevant results. Right. So when I type my name on the Google, it will give thousands of Shardil Chaudhary. Right. So be aware of these limitations, right? So if you're searching an ISI Web of Science for an author with a common surname, it will actually it might get a flood of irrelevant results. Citing tracking only cover this article, not book, while Scopus does include book citation but has weaker coverage of the humanities and the shallow historical record overall. So, if your institution only gives you access to one of these two, know its specific blind spots. Now, Google Scholar's strength and limitations. So, strength, of course, the first one is the searches the full text of the major collection, Gestor and the Project Muse, and Taylor Francis, Agenta, Connect, and other, rather than only abstract and keywords, right? And another strength is free and fast, simple, the best starting point for when searching and for a known title author. Here in this limitations, for example, we have the less comprehensive and the less rigorously structured than dedicated academic databases. Frequently produce redundant results listing multiple versions of duplicate entries of the same article, often links to the article that are not actually freely accessible despite appearing on search screen. An advanced search use or allows restriction by subject, date, author, and publication. Now, most of you have already used Google Scholars without thinking too hard about it, and that's fine, right? But it really is an exciting starting point. If you already know the title and the author of the article, and just wanted to find it quickly, so there is no faster routine. It searches across the full text of many major academic collection, simultaneously, which is something the older indexing databases were built to do. But I want to gently, uh, yeah, but I want you to, but I want to gently push back on the assumption that Google Scholar is good enough on its own. It isn't rigorously structured as ISI Web Science or Scopus, which means you will often see the same article listed in multiple times, sometime at the preprint and sometimes as the published version also. Now, Google Scholar will help you to link an article that still you cannot actually access for free. The advice is simply, or sorry, the search engine itself is open, but the content behind lineage frequency is not. So my search engine itself is open, and or but the content behind link is frequently is not mine. My advice is simple: use Google Scholar as your first quick, and essentially when you already know what you're looking for. But if you're doing serious literature review work, please don't stop here. Go on to the dedicated databases we have just discussed. Now, publisher self-specific full text platforms. Now, here's a piece of information I think many of you will genuinely useful for your own research going forward. If you want to browse the complete back catalog of the specific journal, going to the publisher's own platform directly is often a better strategy than searching through an aggregator like Scopus or Backissue than any third party service does. I particularly want you to remember Gestor's moving wall policy because it solves the frustration of many of you will run into. Students often assume that if their library doesn't subscribe to a journal's current issues, they have no access to that journal at all. That's not necessarily true. All right. Gestor frequently have no access to that. Gestor frequently make older issues, typically from 3 to 5 years back, freely accessible even when you when you have the most recent issues remain unlocked behind a subscription. Now, before you give up on a journal entry, check whether the article you need fall on the accessible side of that moving wall. And Highwire deserves a mention here too. It runs as a non-profit, and over 2 million of the articles it hosts are accessible and make it in on the one of the largest open collection of academic literature online. Now, open access repositories and the self-archiving. We touched on open access briefly in the previous subunit or in the previous lectures, but here I want you to understand the mechanism of how actually it works. Self-archiving means the researcher deposits a copy of their own work either in their university or institutional repositories or in a subject-specific archive, which makes you feel available and practice anymore. All right. So funding agencies and government are increasingly mandating it as a condition of receiving public research money. Now I want you to please pay close attention to this terminology because it matters for how you cite things correctly. A preprint is an earlier draft of an article. Through a repository, you need to check which version you are looking at, and if it's a preprint, you should note that the clearly in your own citation rather than presenting it in a final scholarly world. Now, for searching process or for searching across this whole open searches landscape efficiently, OAI Stir is your best friend. It performs a single joint search across more than 1,000 repositories worldwide, including a huge volume of thesis, dissertation, and even images you want You won't find it on internet or conventional academic databases. And here is a nice piece of evidence to motivate this whole movement. Research has actually shown that open access articles tend to get cited more than often articles stuck behind a paywall. Is simple because more people can read them. Now, thesis, dissertation, and specialized sources. Now, I want to make a specific case to you for taking thesis and dissertation seriously as a research source, because in my experience, students tend to overlook them entirely, right? So think about a doctoral thesis, often represents year of ongoing research, frequently with the literature review more thorough than anything you will find on a published article. That means there is a huge keyword searches on the top will have or will never surface. Now, ProQuest dissertation and thesis, they are the searchable abstract that citation data full text downloadable for free coverage is patchy outside North America. Yes, so basically ProQuest dissertation is the major commercial database here. Though be aware its coverage is strong for North America and noticeably patchier elsewhere in the world, which was just discussed also, and it also captures substantial number of freely available theses through open repositories. So it's worth checking that too. And don't forget, you can simply limit a WorldCat search specifically to those theses and dissertation once you have run an internal query. Now the LexiNexis. I don't know how do you pronounce this. I pronounce this as LexiNexi, right? Now LexiNexi is a slightly different animal. It grows out of a legal and a business research, extremely sophisticated field-based searching, and cover as an enormous range of current affairs and full text material that complements what the more traditional academic pictures or academic databases offers. Now let's bring this together practically. Searching by author, going to the scholar's own homepage often surfaces a fuller publication list, syllabi, and even reprints you won't find in a class or in a debate database, right? So searching by citation lets you move both forward and backward in scholarly time from one trusted source and the one you have found good searches in terms of key journal, setup content, search, and humanities work. This means citation tracing for intellectual history, oyster, and large scale text analysis where bulk access allows it. The core lessons: no single database gives you the whole picture, so that the gap between them are often where your best sources are hiding. So this brings to the end of this subunit or sub lecture. Let's quickly revisit one of the most important ideas we covered this time: the difference between an AI indexing database and a full-length database. Remember, an indexing database is like an old library card catalog. It will tell you an article that exists and gives you the citation detail and abstract, but it doesn't hand you the actual content. A full text database, on the other hand, gives you the complete article, but it usually tied to a specific one database and do everything for you. No, it can't, right? So the smartest researchers move between several of these tools using indexing services to discover what exists, and full text services, open URL links, or open access repositories to actually get their hands on the market or the material. Keep that habit in mind as we move on into our next session on digital scholarship and practice. So I'm going to take your leave now. This is how we're going to conclude this, and I will see you in the next lecture next week. Till then, goodbye.